I want to thank everyone for joining. It's a great pleasure. I hope everybody is staying well. And I want to talk about something that excites me quite a bit is investing into learning programming languages and applying them for different programming applications. One of the really amazing things we have today is the power of the Java ecosystem. The real strength, of course, is in the JVM ecosystem, the Java virtual machine, the Java libraries, the JDK, but all the surrounding libraries and the frameworks as well. But of course, one of the things we can do is the question is how do we navigate that particular terrain? How do we really benefit from writing code to exercise that power that we have with us for various applications? As we know, the JVM platform is one of the most widely used platforms in the world, but thanks to the different languages on the ecosystem, we can leverage different sets of things. Now, in a way, if you really think about it, I look at languages as vehicles. For example, in a given day, you might ride a bicycle to maybe a neighboring park or around your neighborhood. You may take a car to go to maybe a little further away. Oftentimes, we take flights and airplanes to go to a much greater distance and so on. So we do use different vehicles to navigate around on a daily basis. In a similar way, when it comes to programming an application, it really makes sense to use different vehicles or programming languages to get things done. I'm going to talk about a few dozen things that we can do with some of the most popular languages on the JVM. Of course, Java being the most popular of all of them, but of course, we also have languages like Groovy and Scala and Kotlin that we can benefit from quite a bit as well. As it turns out that languages provide their own flavors and things we can do with them, and certain things are a lot easier and makes us more productive to do in some languages than others. Now, of course, as years go by, different languages improve and provide a lot of different features. But the amazing part of this is by learning what we can do today, we can keep evolving in the future as languages evolve as well. So I want to talk about the ease of a few things we can do and about a dozen things or so in the next about 45 to 50 minutes we have with us. So the first thing I want to talk about is how do we go about accessing a file? Now, I'm sure we all have written code to read the content of a file, and that's been a journey in different languages. When I remember that famous ways to read files when I started programming a few decades ago, and I used to kind of imagine, my goodness, why should it take so much effort to read a content of a file? Well, let's take a look at a few examples here on how we could actually read the content of a file. Let's take a very first example here. So I want to start with a little example in Groovy. So I'm going to start with a print line, and I simply want to say new file. So simply just create a file. I'm going to read the exact file in which I'm writing this code. So I'm going to say sample.groovy right there. And then, of course, I'm going to say once I get access to the file, I want to know what the content of that particular request is. It simply said the file is called the sample.groovy. But I really want the content of that file after all. So what I could potentially do in here is to simply say .text and access the text property from it. And as you can see in this particular case, it simply gave me exactly the same content that I wrote in the file, and that's a very elegant and easy way. So there's a text property that Groovy has added to the Java io.file, and it makes it really easy to get the content of that file. That's an elegant way to quickly access. But of course, that was in Groovy, but you may wonder, what if I want to use Kotlin to do something very similar? Well, for its own purpose, Kotlin also does something very similar. So java.io.file, but I want to create an object of this particular class. So I'm going to access the same file again that where the code is in this particular exercise. So now that we got that particular file, I'm going to simply ask it to print it again as an example in here, and that's going to give me the details of the file object we just created right there. But I don't want the details of the the file object. I want the file itself. So I can simply say read text as a function right there, just like the case of Kotlin. But in this case, instead of the property, I'm using a function called read text to access the content like so. Again, a really easy way. And you may wonder along the way, hey, wait a minute, what happened to the exception? Now, it turns out the only language on the JVM that I know of that actually deals with checked exception is Java. All the other languages got together for a dinner and decided we don't want to really deal with checked exceptions, so they don't really care about checked exceptions or don't distinguish between checked versus unchecked exceptions in general. Now, on the same note though, what if I really want to do something similar to this, let's say in the case of Scala? Well, then in the case of Scala, I can do a very similar approach, for example, and I can start with, in this case, a print line again. So I'll say print line, and the print line is going to be a scala.io.source, but I'm going to use a function called from file function. So the from file function is going to give me an iterator. Again, let's just use the file in which this code exists in here. So this is going to give me just the content as a iterator, but I really want the content from it. So I could say, for example, make string, and that's going to give me the content of the file, and in one shot again. So you can see a semblance here of the ease with which we can access the file and get the content very easily. So that really makes us productive, and we don't have to spend a lot of time and effort in the simple task of getting the content of a file, and then we can proceed to really do something useful and meaningful with the file for our domain based on what we are trying to really implement in our applications. Well, see, we talked about reading a file, but what about taking that up a notch? Well, this is something I did a while ago, and I was absolutely blown away by the ease of programming. So I wanted to really interact with some processes. Well, part of my life is in being not just being a programmer, but also being a system administrator. So from time to time, I maintain a few systems, a few servers, and oftentimes I spend my time writing, scripts for doing operations on the server side. I'm a big fan of automation for users. So one of the things I did a few years ago was to go ahead and talk to version control and do some processes when a developer pushes a file into a repository. And there are some bookkeeping operations, background tasks I need to run, which means I have to launch processes quite a bit. And I decided to write that code. And when I wrote that code, it was about, 150 to 200 lines of code. So you may say, gosh, that's not really a lot of code, Venkat, 150 to 200 lines of code. But programmers will secretly tell you that they have really fun, not just writing code, but by rewriting code. So even though the code worked, I really wanted to rewrite it because I wanted to play with elegance and see how I can minimize the code I was writing, even though it was not a lot of code that I had written. And that's when I came across this feature in Groovy where you can start processes very quickly and easily. And I was very intrigued by it. So I rewrote that code in Groovy rather than in the traditional way I had written. And to my surprise, that 150 to 200 lines of code literally came down to about 50 to 75 lines of code. But the code that was there to talk to the external process really shrink down, and that's what I want to show you here today, is how easy it is to bring about such a change in and really accessing a process. So here we are in Groovy, and I'm going to first of all start by again saying a print line, and I'm going to simply access over here, let's say a git help like so. And you look at this and say, oh, look at that. That's just a string called get help. And you're absolutely correct. It is just a string. But on the string, though, I can simply say execute like so. And execute literally takes a string and treats it as a command that you are interested in executing and returns to you a Java process object under the hood. So the process object is ready to fire away and execute on your system. In this case, of course, I'm running git and I'm accessing the git help command, but I can then say the text very much like what I did a few minutes ago, accessing the content of a file. In this case, I'm accessing the standard output of a process in here. So when I run this little code, it's going to tell me what the git help is providing, and right there is the output of git help that's being provided after I executed that particular process and access the standard output. Now, of course, in a similar way, you can easily access the standard input in addition to the standard output and also the standard error if you really wanted to. And again, productivity is improved by using a few different things, and we're not sitting there and juggling with the code and just getting to work. Now, I talked about Groovy and Scala and Kotlin, but nevertheless, Java makes our lives a lot easier as well. And this is one of the things I really appreciate in what we can do in Java. Now, over the decades, Java has provided a capability to do this pattern that is called the execute around method pattern. But nobody really talked about it explicitly in the Java community, but we tend to use it. What I'm talking about is the use of synchronized. For example, when you enter a synchronized block, you acquire the monitors or the lock and you do your work, and automatically when you leave the synchronized block, you are releasing the resources or the logs that you have acquired. Well, this idea of enforcing a policy in a very elegant way, when you enter a piece of code, something happens for you. When you leave a piece of code, a reverse operation happens for you, or a cleanup operation happens. That is a very powerful model, and that's basically is around this concept called the execute around method pattern. So in other words, around a piece of code, there is a pre-op and a post-op you really want to do. Now you may say, okay, Venkat, that's great. We can use the synchronized really nicely, but is there another example of this in Java? Well, in Java 7, we have the try with resources. And try with resources, you put a try a parenthesis and you literally get access to an object in that parenthesis, and then you have a block of code, and when you leave the block of code, the resource is closed because it's expected to implement what's called the auto closable. Well, those concepts are really powerful. One of my concerns really is the synchronized and the try with resource is only useful when you play by the rules of those syntax and capabilities. But what if I want to provide a similar approach for my own code? How do I really go about doing it? Well, you can definitely do that in your own code by using a little bit of a design around this execute around method pattern and making use of lambda expressions. And that's what I want to show you here in terms of what you can do with Java. So let's say we have a class here that we want to work with, and the class I want to really start with in here is a class called resource, let's say. So here is a class called resource that I want to start with, and this resource class is going to contain, let's say, a private constructor called resource. So I made the constructor private because I don't want anyone using this object to class to directly create an object. Then I'm going to say, for example, instance created, and say that I've created an instance of this class already. But then I'm going to provide a public resource, and I'll call it as a op1 for a lack of better words. And within this, I'm going to simply say op1, let's say, performed. And then, of course, I'm going to simply return the current object. So then, of course, in a very similar way, I'm going to provide yet another function called op2. And an op2 is going to simply tell me that op2 was performed. Well, we're almost there, but typically we write a function to clean up, but I'm going to make that a private function called close in here. And the private function close is going to simply say, oh, we will call this as, clean up. So this is going to perform any cleanup operation that needs to be done in the end. Well, that all looks great so far, but if I were to create an object of resource, resource, for example, equal to new resource. Let's imagine for a minute. And if I were to do this and call resource.op1 in this case and call resource.op2, well, the problem with this approach is I often, as a user, I forget to do the cleanup operation. So notice that in this particular case, I did not call the close function. Imagine that the constructors and the close are public for a minute. Well, this is not a good idea because the cleanup didn't happen. Well, even if a user remembered to call the close, they forgot to handle the case of an exception. So if op1 or op2 were to fail, then the close would never get called. Now we got a lot more effort, and programmers have to invest more time and effort in writing that code, which is not very elegant approach to do. So what if we were to be able to streamline this so that the programmers don't have to worry about the cleanup operation? They can just focus their effort on using the resource, and the developer of the resource class comes in behind the scene and takes care of those issues, enters the execute around method pattern. So what I want to do here is, obviously in this example, we cannot call the resources constructor because it's private intentionally. So what I'm going to do is to go to the resource and say dot use and call a use method like so. So what is a use method? So the use method is a public static, let's say a void use, but that takes a consumer on the resource, and we'll call it as a block over here. So this takes a block of code, and obviously I need to import the java.util.function.consumer like so. And once I bring that in, so this takes a block of code in the use method. So as a result, I can go here and say resource and put a little arrow, and I can have a block of code sitting right there. Or I can simply say, hey, now that a resource has been given to me, let me go ahead and call the resource.op1 and then call the .op2 on that particular object like so. So nicely we can call the use function, take in the resource that the consumer is going to provide for us in here, and on that resource we could call op1 and op2. And so what am I going to do within the use method? Well, within the use method I can create a resource, and then I can say equal to new resource and simply say try, and this becomes a consumer that I have provided, which is the block dot accept, and pass the resource that was given to us in here. And then at the end of that block, whether there was an exception or not, I can simply say finally and call this particular function, which is resource.close, and ask it to perform the cleanup operation. So in this case, as we enter the block, the instance was created and we did whatever we want to do. And then when we left our block of code, the cleanup operation automatically happened. So this gives us the power to do what synchronize tries to do what try with resources tries to do, but for our own code. So for example, on a project I was working on, I used this approach to start a transaction and run the code within a transaction, but when I leave the block of code called run in transaction, it took care of automatically rolling back the transaction or committing it based on the situation. So the programmers did not have to really worry about the details of what to do for the transaction and can focus on the business logic that they were working with. So that's one of my favorite patterns these days, and this pattern comes from the days of Smalltalk days, and I've read about this in Kent Beck's writing about this pattern called the execute around method pattern, but I really enjoy using that in modern and more mainstream languages, such as, for example, Java, and of course, you can do this in other languages like Kotlin, Scala, and Groovy, and so on. You probably have seen this happen in other languages where you open a file, but the close of the file happens automatically for you. Those are examples of this particular pattern. Well, now that we talked about the elegance of some of these patterns, that leads to one other thing that I really enjoy, and this comes in the case of Scala. Now, before I talk about this particular feature, you might be wondering and saying, hey, now that Java has default methods, do I really care about this? And I want to really draw the distinction between what you can do with traits and mixins and with Java's default methods. I love Java's default method, but Java's default methods are not traits or mixins. Traits and mixins provide you what's called a stackability. That's one of the biggest benefits of traits and mixins. Stackability is where you can form a chain of these objects, and when you make a call, that call can go through that train or the chain, and so you can stack them up and provide a chain of command. This leads to something like a decorator pattern or a chain of responsibility. As we know, as powerful as the default methods in Java is, you don't have the ability to stack them up. So traits are really powerful for that. Let's take a look at an example of what this can provide for us here. So let's say I have a trait called a friend that I want to start with. And a friend, of course, who is a friend? A friend has a name, but that's really not provided yet as an implementation. But we can agree that a friend is somebody who listens to us really well. After all, a good friend listens, isn't it? So this friend says I am, and displays the name of the friend, and then I'm going to say listening, and that's what this good friend actually is going to do, is to listen to whoever is the friend. So I have a class called human, but the human has a name which is an implementation but extends from a friend trait. So in this context, a friend is almost like a interface that you are implementing. So you may look at this example and say, oh, this looks a lot like default methods in Java. I have an interface with a default method and I implement it. Big deal, right? Well, yes, that's exactly where we start with right now. But then I'm going to write a function called seek help from. And of course, what good a friend is if we cannot lean on the friend when we need. And I have some really good friends I lean on oftentimes. And here is my friend I can ask to listen to my thoughts and concerns. So let's call one of the friends Peter here, and who is a new human, we'll call it as Peter, and say, hey Peter, why don't I seek help from Peter? So I can say seek help from Peter and make the call like so. Now obviously in this case it needs to tell me that I'm Peter and I'm listening, right? So that worked really well. But let's not forget the human's best friend ever. You know what I'm talking about? Dogs. So class animal, and I'm going to say in this case a name, and animals have a name too. And I say class dog, which overrides the name over, in this case, override the name of the as a string and extends from animal. But in this case, of course, I'm going to pass the name, but I say with the friend like so. So an animal with friend, and this is simply saying that I'm mixing in this trait into the dog like so, as you can see in this particular case. Well, okay, so that's great so far. We can say val buddy is equal to new dog, and I say buddy, and in this case, of course, I'm going to say seek help from, and we'll send buddy over to, and dogs are amazing in listening. You can sit and just talk to them, and they're going to quietly listen without really interrupting you a whole lot. So, but then, of course, I write a class called cat. And of course, as we know, cats are amazing, but are cats really friends? You may ask the question. Well, it really depends on the type of the cat you have. Some of the cats are like looking at you like, why don't you just put some food and go back to work? They don't want to really talk to you as much or listen to you for that matter. So if I create Alf the cat and say new cat, and I'm going to bring in Alf over here, as you know, the seek help from cat is not going to go well when I pass Alf to it. That's going to fail miserably in here, as you would expect, because cat cannot be treated as a friend. Now, of course, some cat lovers may disagree with me, me because they may argue that their cat at least appears to be listening to them. Well, okay, maybe you are one of those people with that special cat. So in that case, make no worries. You can say your amazing cat, or whatever the name you gave for your cat, and maybe I'll say my the cat that's amazing. We'll call that cat as the amazing cat. And what do we do with the amazing cat? We can say with friend, and you can mix in, as you can see right there. And of course, this is your amazing cat that you're asking to listen. And of course, that particular cat can be a friend. So that's the stackability I was talking about, a very powerful idea to be able to mix in. And I'm really a big fan of these kinds of ideas where, traits are really compile time mix-ins, if you want to think about it that way. And that's basically what we were able to do with that particular example in here, as you can see. So those are really capabilities that can strengthen our design abilities in the languages as we program in. Well, the next thing I want to talk about here is to another feature I really admire, and you can do this in different languages. You can do this in Java, you can do this in Kotlin, Groovy, and Scala. Almost any language today provides this capability, but I want to show this to you in Java to see how we can actually do this in Java. So let's say we have a list of string, we'll call it names is equal to arrays.asList, and I'm going to say we can create some names. Let's say we have Jane, we have Bill over here, and maybe we have Bob over here, and then maybe we'll have Sarah here as well. So we got a bunch of names given to us. But what I want to do is to be able to convert these names into uppercase, let's say, but I want to join them into a comma separated string. If you're writing a for loop to do this, life becomes really miserable because you have to really concatenate to a string, put a comma in the end, but not in the last place. What a mess to deal with. That becomes too hard to program, verbose and error prone. Or what you can do is to simply say, hey, take the names and get a stream out of it, perform a map operation, and convert the names to uppercase like so, but then in the very end call the collect function. But to the collect function say joining and simply use a comma to say that you want to join with a comma in the very end. So where does this actually come from? Well, this comes from the collectors API, and I'm going to bring in a static import like so in there. So the joining function comes in from the collectors, and I can simply focus on writing the code without having to really worry about a lot of different details of how to go about writing that particular logic, and that's taken care for us without having to do a lot of work. So in this case, of course, I'm going to just bring in the import of java.util, and we can see that we can simply use the join function, and there's no comma in the very end of this, and it really concatenates the results in this case with a comma, and I don't have to waste my time and effort trying to figure out how to strip out that comma from the very end. And almost everybody has dealt with the problem, but something we don't have to deal with in here, and we can focus. The same approach appears in different languages. Like I said, if you're programming in Kotlin, programming in language like Scala, you can readily look for the variations of this to be able to join your string. You already saw this in the case of Scala. I used make string earlier. You can specify make string what you want to concatenate with. In that case, I didn't give anything to concatenate with, but you could potentially give something for it to concatenate with as well. Now, one of the things I care about a lot is not just programming, but efficiency. Sure, elegance is really important, but beyond elegance, we want performance, we want efficiency of the code as well. Now, unfortunately, though, when we are writing a piece of code, it's possible that we tend to forget, efficiency, and we tend to favor elegance, but that's not going to really help. So let's look at an example here in the case of, Kotlin. just to entertain the thought how this would actually end up helping us. So I'm going to say a compute function that takes a value of n, and all it's going to do is return an integer in the end. It's a very trivial example. It simply returns n times 2, or imagine this is a simulation of a very complex and time-consuming operation. So within this, I'm going to simply say called, so we can see that the function has been called like so. Now, in this case, if I say x equal to 4, and as we know that if x is going to be a value of 4, I can write the code like this. I can say if x is greater than 4 and I can say compute of, let's say, x is greater than, let's say, 7, then I could maybe output, maybe in this case, I'll go ahead and print it and say this is path 1 that I want to print. On the other hand, I could do a else block, and in this case, I could simply say maybe path 2 like so. So if I were to run this code, you would expect this to say, hey, x is not greater than 4 after all in this particular case, isn't it? So let's go ahead and fix that error in this particular case. Oh, I forgot this. I wrote in the Groovy code rather than in the Kotlin code. So I'm going to go ahead and copy that over to the KTS file. So let's go back to the KTS file and run the code. So notice that in this particular case, so you can see that you have the function, and when you run the code, it says path 2. Well, here's the good news, right? We did not execute the compute function. Why so? Because of short circuiting. But if you really needed that really more than once, well, how do you then do this? Well, you can say val temp is equal to compute in this case of x, and then you could replace this with a value temp like so. But the problem in this case is, unfortunately, the compute is executed even though we really don't need that particular value. Oh, darn it, what can we do? Well, you can give a clue to the compiler and say, hey, do me a favor. I want to mark it as lazy and compute of, let's say, that particular value that's given, but don't evaluate it unless you really need it. So you're able to mark it as lazy, and notice it did not call the compute in this particular case. But on the other hand, if I say 5 like so, because x is greater than 4, you can see in this particular case of execution, it did call the function, but if you don't really need it, it bypasses the call. You can do a similar thing in the case of Scala as well, using a nice little lazy syntax. Well, what about Java? Well, you can create your own lazy in Java using something like a supplier, or you can use tools like or libraries like Project Lombok and achieve a similar result as well. So it's a concept worth exploring if you want to really think about eliminating calls that you don't really need to process. Well, that leads to one thing that we're going to see in Java very soon, which is the pattern matching syntax. I'm a huge fan of pattern matching. I've done that in many different languages, and I'm really eager to see that come through in Java. But I want to show you a little bit of an elegance of that here in the case of Kotlin right now. So let's go back to Kotlin here and say process is a function I want to write, which takes an input of just about anything you provide to it. But what I want to do in this particular function is to simply, let's say call process with a 1, but I want to call process with a few other things, maybe a 15, maybe a string, let's say hello, or I want to call this with a 1.3 as a piece of data. So now I can go back here and say when input, whatever the input is given to me, and I can then say in here, if it is a 1, I want to simply say print line, and I say 1. But what if it is not? I can say else and simply print out, let's say, whatever that was given to me. So in this case, I say if it's a 1, go ahead and print 1. If it's not, just say whatever and process that. And I'm a big fan of this, and you probably recognize you can start doing this in Java very soon to a great degree, if not already to a certain extent. But in this case, I say if the value is in 13, let's say to 19 in the range, then I can simply print out, let's say, a teen like so. So this tells me the value 15 is a teen, not a 1, not a whatever. And you can see the output that tells me it's a teen like so. In a similar way, I can also say string, and in this particular case, we can then do a print line, and I can say it's a string, and we can then specify that it's actually a string and provide that capability like so. So that becomes a very nice, elegant way to do pattern matching, and like I said, very soon you can do this to a great extent in Java as well. And so the languages are adopting this capability of doing pattern matching. And this leads to one other capability, which is the beautiful ability to do, if you will, auto casting. Well, you can do this in Java today very effectively, but I've seen this in other languages like Groovy and Kotlin. So let me show you that really quickly in here. You don't have to endure the pain of typecasting over and over and over. You can say it's a string of length like so, and notice right there I can specify the string that I have in here input, but obviously I don't want to print the word hello. I want to print the word's length. After all, that's what I'm really after. So then I can say dot length and access the length of that particular object very elegantly, as you can see, and that's going to tell me that in this particular case the length is a 5, as you can see. So I like to call this as a smart casting. Java calls it as instance of a pattern matching, but whatever we call it, we benefit. So the point really here is, as you know, the input doesn't have a length. So if I were to go up here and say input dot length like so, you know, there's no length property on a integer value, so that's not going to fly. You got an error at that point. However, because a string does have a length property, it was able to smartly decide that within the context of right from where the cursor is right now in here to the end of that particular object is a string, and so you're able to call the string properties on it very elegantly, and that's basically what you saw here. So in about the next 10 minutes or so we have with us, I want to show you a few more things, a little bit to a greater degree and a few to a less degree due to our time constraint here. So one of the other things I really like about languages in general is the sheer elegance they provide in terms of what we want to create. Now think about having to create an XML document. I don't think there is anybody in this group who goes to work saying, oh my gosh, I'm so happy, I'm going to write code that vomits XML today, right? Well, we don't like XML, and very time we are required to work with it, we wear a thick pair of gloves and protective glasses and work with it, right? Well, but what if you really have to generate an XML document? Well, here comes the charm. I'm going to say langs is equal to, let's create an array of languages, if you will. So here is a C++. I'm going to say, and the author of the language, let's say Strustrup, who created it. So I'm going to say the language authors I'm going to mention here. Then let's go ahead and say Java, and let's provide the author of the language, Kotlin. And finally, let's put one more here. Let's say another one, let's say Lisp, and we will provide the author's name. And so a bunch of languages and authors is what I have right here. So that's a good start for now. So now that I have the list of languages, let's start by simply saying I want to print the languages, but I want to create an XML document of these languages after all as a representation. So what I'm going to do instead is I'm going to say a builder is equal to, in this case, I'll say new Groovy dot, let's say XML dot markup builder. So I'm a big fan of these kinds of DSLs or domain specific languages. And you can see in this case, I say languages, and I'm going to just start with that without anything even further. But at this point, when I exercise it, notice how a little XML baby popped out right there. Then what you can do is to provide a context and say langs dot each, and for every single language that you see, you want to provide a child element within that. But what do I want the child to be? Take the key and the value that's given and simply say language and provide a child element like so. So now you can see the children element, come in for each of the languages. But then I can say I want to provide the author and say what the value is. That becomes a child element of the child element, and you can see author's true strip appear right there. But what about an attribute? And that becomes really elegant and easy. You can say name with the value of key becomes the attribute that I want to use as well. So if you're in the business of having to create XML representation, you can make that relatively an easier job as well by using these kinds of builders. Similarly, Kotlin also provides a few different builders, with the difference being in the case of Kotlin DSLs, you have the power and the benefit, if you will, of really being able to use a DSL with a fairly decent amount of compile time verification as well. That's one of the powers that you get out of languages that provide the fluency to create DSLs, but also provide capabilities to verify whatever to a limited extent, depending on the language, is very powerful. Again, that brings back to my desire to write elegant code that's expressive, easier to work with, easier to maintain, and those are really good traits that I always look for in languages. And again, as languages evolve, we can see these trends happen in multiple languages, but knowing these across languages strengthens us as programmers to apply these ideas and exploit some of these design capabilities. Well, having said that, another thing that intrigues me is this idea of tail call optimization. I'm going to just mention this a few minutes. I won't go into too much detail in here, but the idea behind a tail call optimization really is that you want to be able to call recursive functions. We all have fascination for recursion, but the problem with recursion is every time you call a recursive function which calls a recursive function, you are building a stack, and if it's a large value that you want to process, you might blow up the stack, which is really a sad thing. But with tail call optimization, what happens is the compiler rewires your recursion into a simple iteration. So even though to the human eye, it looks like a recursion, and it's a recursion as far as the code is concerned and the algorithm and the logic is concerned, the compiler rewires it as an iteration. So as a result, there is no overhead of the stack expanding during runtime. Well, languages like Scala and Clojure and a few other languages on the JVM provide that capability. Now, of course, what would be really cool is if that becomes available on the JVM as a first-class citizen. Well, the rumor has it that might happen in the future thanks to things like Project Loom. So I think this is something we can look out for in the future. I'm not going to go into the details of the implementation in here, but it's intriguing, and I've used tail call optimization quite a bit in various places, but I'm always look for that feature when it comes to a language where we can exploit it. Even though that's not available in the case of the JVM and the Java language yet, this is something that's been experimented in other languages, but hopefully this becomes a native capability in Java or the JVM more so, maybe in the next few years. I'm eagerly waiting for it. Well, we're going to wrap up the next about 5 minutes or so we have with us by talking about two other things that I'm really, really curious about. When it comes to creating DSLs or fluent syntax, it is always intriguing for me to be able to create domain-specific methods. I remember an example where I was working on a project for an insurance company, and we had to write a lot of code that would take dates and compare the dates and do domain-specific insurance-related policy extension and policy validity functions. Well, rather than writing static methods and passing dates around and policy around, we were able to exploit the date object to add domain specific methods, so it became a lot more fluent and easy to work with. Well, you can do this in languages like Kotlin today. Even though Java provides default methods, they're not really extension functions. Well, language like Kotlin really provides this capability of writing extension functions. So I'll give you an example of this in here just to see how that works. So let's say we are going to say hello as a output when we run the code. And of course, in this case, it just prints hello. But if you're meeting a friend after a long time, especially after the current time we live in, if you're going to be traveling around and seeing your friends, you're not going to meet a friend and say hello. You're going to scream at the top of your lungs, hello, isn't it? So you want to be able to shout at your friend. Well, obviously, I would definitely do that because of excitement seeing friends. So in this case, of course, it says shout is not a function in the case of a string. How sad I think it should be. So we take the string after all, and you simply say shout is a function, and all I'm going to do is simply call to uppercase in this particular implementation. So we took the string class, yes, the sacred java.util.java.lang.string, and we are saying, hey, let's go ahead and add this at this particular point. So essentially, in this particular case, you can see we are simply taking the function. Oh, it says use uppercase instead with all the lowercase in it. So uppercase, let's go ahead and say uppercase. So essentially in this particular case, we are just routing the call to this other function, as you can see, and we are calling the shout function, as you see in this particular case. So essentially, we are introducing a new function called shout on the string. But of course, behind the scene, the Kotlin compiler simply doesn't do any bytecode hacking. Instead, it routes this call as a function to which it passes the hello as a first argument, a nice little syntax sugar. Well, this can lead us to writing a really fluent code, but one thing I really like is very highly expressive code, and that's the last thing I want to show you in here. For example, let's say I have a class called car. This can be really useful to not only create DSLs, but also to just simply make the code more fluent. So I'm going to say a car equal to car. I create an object. I say car.turn, and I'm going to say left like so. And then I can say a dot turn, and then I can say right, for example. Well, yes, that's a syntax, and we all have written code like this. And you can write a function called turn, which takes a direction, which is a string, and I'm going to return a car from that function, and within this function I say return this. But before I do that, I'm going to simply say turning. Let's go ahead and say whatever direction we are turning, I'm going to just display that like so. Now, when I run the code, obviously, it's going to tell me car is turning left, and then it's going to say turning right, and that's basically what we are expecting to see as an output. Well, okay, that's awesome, but this is very noisy code. Wouldn't it be really nice if we were to remove all that noise and simply say, hey, why don't we simply say car turn left and turn right like so? Well, you can make that work by telling Kotlin one little thing, and that to treat this function as a infix function. So by saying infix up there, you can see that you're able to make that elegant code work. And like I said, I'm a really big fan of ability to code like this, where you can remove the noise of the dot and the curly braces and the parentheses and the dots, and that can make our life really easy in terms of writing expressive code, and also opens the door for creating DSLs or domain specific languages. So in about the 50 minutes we had with each other, I presented about a dozen things we can do with different languages, and programming languages really excite me in terms of their capabilities. But one of the reasons I like to do these things is not only that I can learn about these things in different languages, but when I sit down to design software, I tend to really push the boundaries within the language I'm using as well, and tend to really write a better quality code, a more fluent code, and it just simply excites me and brings new energy into writing better software over time. I hope you found that useful. I want to thank you again for taking the time to join us here, and do stay safe, and thank you very much. I really appreciate it. Stay well. Thank you.
I hope that dozen of cool things will help our developers to build the better applications.